Phil Pokorny with Penguin Computing. We're here at Supercomputing 2012 in Salt Lake City, and I'm here to tell you a little bit about the Penguin Computing booth. The Supercomputing conference is really important to the HPC industry because it brings together all of the players in this market space, from high-performance interconnects to high-performance computing to software vendors, and it gives them one place where they can really see all of these different technologies. For Penguin Computing, this is really great because we play and provide so many of those technologies to customers in a single integrated package. It's a great way for us to show off the wide variety of technologies that we can provide to customers in a single integrated package that makes it much easier for them to get started doing the work that they need to do. Supercomputers have really taken over science and research because computational methods are supplanting sort of physical testing and physical experiments, right? So it's no longer possible to set off a nuclear bomb. It's, we're working with industrial customers that rather than building physical samples and testing them until they break, they're actually simulating these systems in the computer and then using physical systems to verify the simulations. They can run many, many more iterations of simulations than they can actually build physical models. So this lowers their overall costs and lowers costs to consumers. It also improves their reliability because they get a better design out of the gate with fewer problems. And that's all enabled by the large amount of computing power that we can now deploy with a supercomputing cluster. So the AMD 6300 Opteron processors are a great fit for supercomputing because they offer a huge number of cores and a great floating point performance, so that we can build cost-effective clusters with a lot of floating point hardware to attack these problems that I was talking about earlier, where we're using computational capacity to lower the cost of finding a solution to the questions that are being posed by science and technology. Here at the Supercomputing Show, we're showing our Altus 1850, 1750 platforms certified for Cloudera. Cloudera is software technology that enables big data analysis. So if you have a huge amount of data, you need to sift through that trying to find the needle in the haystack. And by using AMD processors, we can deliver a large number of cores to do that sort of sifting operation. And this is a case where the Opteron 6300 processors, with their class-leading numbers of cores for running Java-type workloads, is a great technology fit for these big data problems that are solved by the Cloudera stack. And we're excited to have gotten our platforms certified with Cloudera so that customers can be confident that when they buy a Cloudera, a compute solution from us for big data, that it comes with the confidence of a Cloudera stack certification. Penguin Computing has been a long-time partner with AMD, and we're really excited to be offering the Opteron 6300 series processors as upgrades to our existing Altus line. We have a full line of Altus servers, from 1Us to 2Us to half-depth, 1Us to workstations, platforms that can take GPUs. So really, whatever it is a customer wants, we can provide a chassis that delivers that capability with an Opteron 6300 processor in it. AMD's 6300 processors continue the legacy of just socket drop-in replacement CPU upgrades, which is a great way for customers to protect the investment they've made in a chassis and give it a nice sort of midlife performance boost by just replacing the processor. They can keep their memory, they can keep all the I/O cards, keep all of the cabling and networking and rack infrastructure that they have. The separate product line is their accelerated processing units, or APUs, and the most recent example of this is the A10 5800K, which is a single processor that includes not just a CPU but also a GPU, and they're both tightly coupled, connected to the memory in a way that lets the GPU quickly access data that's in memory. And we've taken this technology and done a first in the industry, which is turned it actually into a compute node. We deployed this at Sandia Labs, a 104-node cluster with the first generation Llano parts, and we've now upgraded them with the next generation Trinity parts, the A10 5800K. Here at Supercomputing, we have examples of our APU compute nodes. We have a 2U Altus 2A20 node with the Trinity A10 5800K processor in it. That chassis allows you to have multiple high-performance compute cards, and so we can show customers what that looks like, what the software load runs on it. We're also using that as a platform to demonstrate a new product that we're introducing here at Supercomputing called Power Insight, which is a subsystem level power monitoring technology which allows you to tell not just how much power the whole chassis is drawing, but actually how much power is going to the CPU socket, how much is going to the hard drives, how much is going to the fans, to the memory, and really let researchers who are increasingly power aware about their algorithms, not just how fast does this algorithm run, but how much power does this algorithm draw, them insights into the internal workings of the system to help them tune their algorithms for the best performance, the best power efficiency. Thank you for visiting the Penguin Computing booth at Supercomputing 2012.